identify types of functions from a graph. So first we have a linear function which is a constant rate of change. So this is adding or subtracting consistently, the same number over and over and over, whereas exponential is multiplying or dividing over and over and over. Now, in general, if we're looking at graphs, okay, a linear graph, if we start somewhere and say, okay, we're just going to add over and over and over, we end up with a straight line. So when you're talking about a linear function, the graph is a line, which is great. Now, exponential function, you're multiplying. And if you think about repeated multiplication, that gets big really quickly. So we could have something that looks like this, and it kind of curves and goes all the way up. We also, remember that we could also be multiplying by a fraction, which is the same as like dividing. In that case, an exponential function would look like this. Okay, so you'll notice a line, whether it's positive slope, negative slope, it's going to be straight line, right? Whereas an exponential has some curvature to it, okay? But it's also important that we are looking at the proportional rate for the exponentials or the linear functions if we have a constant rate of change. Okay, so first, let's look at this one. Now, at first glance, this looks like a line, but we have to check, do we have a consistent? So remember we talked about like, I shouldn't say that, if you've watched other videos, you have this idea, but we want to look at consecutive points and how they differ. So this point down here has an ordered pair of -2, -3. This one is -1, -1. This is 0, 1, and 1, 3. Okay, so as we go from this, like the x value tells you the point that it is, so we're really comparing the y values. If we go from, on our graph, left to right, so we start here, in -3 to -1, we add 2. -1 to +1, we add 2. 1 to 3, we add 2. There is our constant change. So this is linear with a constant change of +2. Now this next one is a curvature. Okay, so at first glance, we can tell it's got a curve to it, so it looks to be a little bit exponential. Now let's check. Again, we're looking, and maybe we don't want to try these are fractions, but if we look at these 3 points in order and look at the ratio, from 1 to 3, I multiply by 3. From 3 to 9, I multiply by 3. If you want to play with fractions, from 1/3 to 1, did I multiply by 3? Yep. So all of these work from 1/9. If I multiply by 3, I get 1/3. So it works that this is exponential, and my proportional rate of change is times 3. All right, let's identify the following as linear, exponential, or neither. Now, if it's important that as you're looking at these, you do check your ratios. Okay, so when we're looking at the one here on the left, the letter A with this curve that goes down here, if we look left to right, from 4 to 2, well, that's dividing by 2. From 2 to 1, I divide by 2. From 1 to 1/2, I divide by 2. So this is exponential, and we could say divide by 2, but often we talk in terms of multiplication. Dividing by 2 is the same as multiplying by the reciprocal, or it's multiplying by 1/2. In letter B, we are looking at this. So as we go from left to right, we have our numbers in order. So from 4 to 2, we subtract 2. From 2 to 0, we subtract 2. So this is linear with a constant change of -2, right? We can add a -2 if we want to talk about in terms of addition. All right, and the last one. Well, friends, you can see this is not a line. We can see this is not a curve that looks like exponential. But if I look at my values from left to right, from 2 to 4, I multiply by 2 or I add 2. From 4 to 2, I either divide by 2 or I subtract 2. Those are not consistent, so it would be neither. Just remember, as you go from left to right and you compare the y values, that is where you should be seeing your consistent addition or subtraction or the consistent multiplication or division.